Thank you. Thank you very much, Frances, and thank you, Bankinter Foundation, for giving us this opportunity. So I will briefly tell you about some examples of innovations in Spain. And we are lucky enough to have very good brains in the country, so very good universities. So my job, as I highlighted yesterday, is quite easy. It's bring them into the real world, right? So Aqualia, we are a global water operator present in 18 countries. So probably some of the people here living in Spain, they pay bills to our company. So welcome to the country. And Spain is let's say it's a funny country regarding water, because probably all of you that are not living in Spain, that come from abroad, you might think that Spain is a water-stressed country, which it is. But there are huge differences between the north and the south of the country. And I come from the north. Something I would like to highlight, and that's why I chose this picture first, is that in the north of the country, where the dams are very small and we typically never run out of water, it's happening, probably due to climate change. I'm not an expert in that topic. There are some in the room. We can discuss it later. But even in my region, I live in the northwest corner of Spain called Galicia, where everything is green, we are having troubles with water. And in the other corner of Spain, in Catalonia, this is a picture from an industrial park in Tarragona. They are also facing, you heard probably about Barcelona running out of water, right? So that's a good example I wanted to highlight. This is a wastewater treatment plant for an industrial park, and it's a joint effort between the petrochemical sector. So companies, chemical and petrochemical companies have put together a new entity, and they hired us to build the wastewater treatment plant, to do a joint collaboration, which is something key in our sector. And that's the world I wanted to highlight as well, together with innovation. So they wanted to do a joint effort and also to reuse water. So now we are working in the second part of the project. Here you see ultrafiltration biological reactors, MBRs, to get rid of the dirt of the wastewater, but now we should work on the desalination part, on the osmosis part, to bring back this water into the industrial park. Then let's go to the municipal. So you probably, I don't know how many of you know and are aware that in Spain we lack financial investment in water, especially in the municipal sector, where it has been measured some years ago. It looks like we only cover with the water bill 80% of the OPEX. So we are not fulfilling the EU laws, regulation, etc. So our thought was, how can we do more with the infrastructure we have? Because we are not providing the money to invest in new infrastructure. So we thought, okay, 99% of the wastewater treatment plants in our country are based on activated sludge. You know, it's a patent that is from the 1914, so more than 100 years old. So water is not really a sector where innovation are coming every year, right? It's not Apple, Microsoft, Amazon, etc. So we thought, okay, I have an infrastructure. Let's put some sensors, as Jaime highlighted, in the dirty water part. It's complicated, so measuring flows in the tap water sector, it's easy. In the dirty water, it's very complicated. So we decided, let's learn a lot digital, let's become digital also in the dirty water sector. So we put lots of sensors, we invest lots of money, but this money, it's much lower than the money that once you have the digital information, you need to put into the system to make things better and more sustainable, right? Okay, so what we did is transform our activated sludge basins in biofilm systems, in our case with aerobic granular systems, so that I can spare some concrete in my wastewater treatment plant. So I won't spend more money in concrete, but I will free some space. Okay, so without a too heavy investment, I can optimize and increase the capacity. And why should I do that? Because the rain pattern is changing and evolving. So I need some free space to store all this rainwater. Because another issue we have is that most of the sewer in Spain are combined sewers. So we are mixing rainwater with dirty water. In the south, it's not a big issue, even though some days of the year it rains a lot. But in the north, it's a huge issue. So we made the effort to measure how much rainwater is entering our sewer. For us, as a global water entity, it's quite easy. I will tell you an example. The Vigo municipality. I sell as tap water 50,000 cubic meters a day of water. Do you know how much I treat in the sewage treatment plant? 4 times more, 200,000 cubic meters a day. So I already knew the big numbers, but we are now measuring how the problems are. Why? To invest wisely. Where should I put my efforts and my money to repair things that are not working well, right? Okay, so that's the fancy. Now the Amazon and all the digital solutions help a lot to build fancy new things, doing a work much better than some years ago. So we transformed one of our basins into a fancy aerobic granular sludge reactor, freeing some space to be able to collect some rainwater during the rain event, protecting the sea, because this is Moaña, and someone told before about harvesting resources in the sea. In our region, we raise a lot of mussels. All these mussels harvesting, they need to rely on a good sea quality, so I need to protect it. So this is a very important thing to stop the floodings, and especially the combined sewer floods, okay, or spills. That's another example I like a lot. So we put sensor, and we worked a lot on a mathematical modeling of the sewer. We want to know mathematically all what's happening, how much flow I have. And then it was raised this morning that wastewater is somehow telling us how the society behaves. It was a couple of years ago during the pandemics, we measured how a variant of the SARS-CoV-2 evolved in Vigo City. And we realized that just in 3 weeks, I don't know if you remember, by that time, the Epsilon variant took over the Delta one. And it was very fast. But with the sewer, we were able to measure it in a very short time. And we did it in our lab, in a wastewater treatment facility, which is something that probably 10, 15 years ago, it was hard to believe. Another project that we are working hard on it is how to become energy positive in the wastewater treatment. And something I like a lot is anaerobic digestion, and here Jürgen and Juan are experts in that topic. So how can I produce biomethane out of the sewage, okay? So here what we thought is, why couldn't I mix the biowaste? And it's something we copied from the States, because in the States, you have seen probably in the movies and the ones that live there, you have grinders at home. Here in Europe, it's not typical. But the water is mixing together this biowaste plus the urban wastewater. So if then I have an anaerobic reactor directly, as a first step in my wastewater treatment plant, I will harvest all the energy potential from both. So I skip the truck that has to load the biowaste, and I need to collect it separately at home, which is annoying. So I can do this job both together. But then, so what we did is to develop 2 technologies, the anaerobic and membrane. So we put an ultrafiltration after the anaerobic digestion step. But then, depending on the use I do of this outlet wastewater, maybe I can use the nutrients for direct fertirrigation, but sometimes I can't. So sometimes I need to remove the nitrogen. And here, together with Juan Lema and his team at University of Santiago, we developed a fancy technology based on bacteria that is able to remove nitrogen without using too much energy. So that's how it looks like. That's how the bio-waste is being grinded in our demo plant. And we built a quite big, you can see the dimensions here. We are able to treat 500 inhabitants equivalent in our demo plant. So this is a joint effort with universities. We need to share our knowledge. We need brains. We need clever people to help us to develop new technologies that we can put in our toolbox. So coupling together anaerobic reactor and ultrafiltration processes, we can harvest bioenergy, water fit for reuse, and biosolids. Then, as I was highlighting, we also need to remove nitrogen wherever I cannot discharge it. So we developed this fancy ELAN technology based on bioprocesses together with the University of Santiago. You see here the picture of our first full-scale realization. And of course, my boss used to tell me, you know a lot, but I cannot have at each wastewater treatment plant a PhD working on it. So please put all this knowledge in very simple things that an automat can do, okay? So we need to bring all this knowledge into very simple things. Then David highlighted it this morning. We are also working hard together with other companies, entities, universities in all Europe to split grey water and black water and treat them separately and reuse grey water and also treated black water. Okay? This is a building we have in Vigo, and where it was built from the beginning with this strategy. I think in the future we should think about new neighborhoods based on this type of solutions. Another patent we developed with Juan and his team is based on phosphorus recovery from black water or wastewater treatment. And then to finish, we were talking about the rainwater. What do I do with rainwater once it's splitted and separated from wastewater? Here, a nice example of cooperation between a municipality, architects, civil engineers, and the water sector. They renew a part of the city that was degraded because runoff water was going there without treatment, and they built this fancy park. Of course, it cost 30 million euros. And they are working on a second phase. But anyone or everyone or the whole neighborhood has gained with it because they are treating their runoff water. It's not entering the combined sewer. And then all this region or part of the city has evolved and now is gaining more interest. And finally, in Aqualia, we also work a lot with photobioreactors. So getting rid of the blowers in the wastewater treatment plant and the microalgae or phototrophs are doing the job for us. Thank you very much.
Thanks.